Here we have a problem on arithmetic progression. Okay, let me go over the question. Consider an arithmetic progression of positive integers whose sum of the first 3 terms is 54 and the sum of the first 20 terms lies between 1600 and 1800. Then its 11th term is. Using the given information, we have to find the 11th term of the arithmetic progression. There is a formula in arithmetic progression to get the nth term, that is an equals to a1 positive n negative 1 times d. Here this a1 represents the first term of the arithmetic progression and this d represents a common difference. Okay, if I want to get the 11th term of an arithmetic progression, what I have to do is I have to plug in 11 into the formula over here. Then I'm getting a11 equals to a1 positive. When I plug in 11 over here for n, 11 negative 1 is 10, that is 10d. Okay, so a11 equals to a1 positive 10 times d. To get the 11th term, I need the value of the first term and the common difference d. Using the other information, we have to get the value of this first term a1 and common difference d. Okay, for that, let me consider the first piece of information, that is sum of the first 3 terms is 54. That is S3 equals to 54. S3 represents the sum of the first 3 terms. In arithmetic progression, there is a formula to get the sum of first n terms, that is Sn equals to n over 2, 2 times a1 positive n negative 1 times d. So this is the formula we have to get the sum of first n terms. Okay, here to get the expression which is equal to S3, what I have to do is I have to plug in n equals to 3 over here. When I plug in n equals to 3 over here, I am getting 3 over 2 times a1 positive. When I plug in n equals to 3 over here, 3 negative 1 is 2d equals to 54. Okay, now to get rid of the fraction 3 over 2 which is multiplied over here, I'm going to multiply both sides of the equation by the reciprocal of this fraction, that is 2 over 3. Let me do it. So 2 over 3 here times 2 over 3. Here this 3 will cancel out, 2 will cancel out, and we get 2 times a1 positive 2d equals to 3 goes into 3 1 times and 3 goes into 54 18 times. 2 times 18 is 36. Okay, here I got an equation in terms of the first term a1 and d, that is 2a1 positive 2d equals to 36. Okay, now let me consider the second piece of information, that is the sum of the first 20 terms lies between 1600 and 1800. That is the sum of first 20 terms lies between 1000, let me write over here. Okay, so the sum of first 20 terms lies between 1600 and 1800. So we can write the second piece of information as an inequality as I've written over here. Okay, 1600 less than. Now to get the expression which is equal to S20, the same thing we have to do. We have to plug in n equals to 20 over here. Then I'm getting 20 over 2 times 2 times a1 positive. When I plug in n equals to 20 over here, 20 negative 1 will be 19 times d less than 1800. Okay, now let me continue over here. So 1600 less than, when I divide 20 by 2, I'm getting 10. So times 2 times a1 positive. I'm going to split up this 19d as 2d positive 17d. Okay, even if I add 2d and 17d, I'm still getting 19d. Why should I split up this 19d into 2 parts, 2d positive 70? Because I have the value for the expression 2a1 positive 2d, that is 36. If I want to use the value 36, I need this expression. For that purpose, I'm splitting up this 19d into 2 parts, 2d positive 70, so that I'm getting this expression exactly over here. For this expression, I can plug in this value 36. Okay, so here we have less than 1800. Okay, 1600 less than 10. Here for this one, we can plug in 36 positive 17d less than 1800. Here in the middle term, the complete expression over here is multiplied by 10, and this 1600 is a multiple of 10. This 1800 is also a multiple of 10. Since all the 3 terms of this inequality are multiples of 10, better we can divide all the 3 terms of this inequality by 10 to make the number smaller. If the numbers become smaller, it will be easier for us to do calculation. Let me divide this one by 10, the middle term by 10, and this one by 10. So here 0 will cancel out. Let me do it. And here this 10 will cancel out, and here 0 will cancel out. So we have 160 less than 36 positive 17d less than 180. Now we can solve for d in this inequality. For that we have to get rid of all the values around d. First let me get rid of this 36. For that we have to subtract 36 from all the 3 terms of this inequality. When I subtract 36 from all the three terms of this inequality, so here 36 and 36 will cancel out. When I subtract 36 from 160, I am getting 124 here, less than 17D, less than. When I subtract this 36 from 180, I am getting 144. Okay, now to solve for D, I have to get up this 17 which is multiplied over here. For that, I have to divide all the three terms by 17. Okay, let me do it. 17 here, 144 by 17. The 17 will cancel. When I divide 124 by 17, I am getting a long decimal value, that is 7.29, and it keeps going less than. Here we have D. Here, when I divide 144 by 17, I am getting a long decimal value, that is 8.47, and it keeps going. Okay, according to the information we have over here, all the terms of the given arithmetic progression are positive integers. Since the terms of the given arithmetic progression are positive integers, the common difference D also must be a positive integer. So we have to consider the positive integer value between these two positive values, 7.29 and 8.47. There is only one positive integer between these two positive values, that is 8. So therefore the value of the common difference D is 8. Okay, now what I can do is I can plug in D is equal to 8 into this equation and solve for the first term A1. Okay, now let me do the stuff over here. So now let me take that equation as it is. It is 2A1 positive 2D equals to 36. Okay, before I'm going to plug in D equals to 8 into this equation, let me divide each term of this equation by 2, because everything is a multiple of 2. When I divide it by 2, the numbers will become smaller. Okay, now let me divide the first one by 2, the second one by 2, and here 36 by 2. So 2 will cancel, here 2 will cancel, 2 goes into 2 one times and 2 goes into 36 18 times. Here I am getting A1 positive D equals to 18. Now we can plug in the value of D, that is 8 for D over here. Then I am getting A1 positive 8 equals to 18. Okay, now let me subtract 8 from both sides of this equation to solve for A1. Then I'm getting A1 equals to 18, negative 8 is 10. Okay, now I got the value of the first term A1, that is 10, and the value of the common difference already we got it, that is 8. Using the values of the first term A1 and the common difference D, we will be able to get the value of the 11th term of the given arithmetic progression. Okay, now let me erase the stuff and continue the problem. Okay, here we got it that A1 is equal to 10 and D equals to 8. Okay, now already we know the common term, the nth term or common term of an arithmetic progression. The formula is AN is equal to A1 positive N negative 1 times D. Okay, now to get the 11th term, what I have to do is I have to plug in N equals to 11 over here. Then I'm getting A11 equals to A1 positive. When I plug in N equals to 11 over here, 11 negative 1 is 10 times D. Then A11 equals to, okay, now we can plug in 10 for A1 over here and 8 for D over here. Then I'm getting 10 positive 10 times 8. Then A11 equals to 10 positive 10 times 8 is 80. A11 equals to 10 positive 80 is 90. So the 11th term of the given arithmetic progression is 90. We find 90 in answer choice A. The correct answer choice for this question is A, 90.